In this session, I'll be explaining a few more problems on Z parameter. Find the open circuit impedance parameter for the network shown. Determine whether the network is symmetrical and reciprocal. Open circuit impedance parameter means Z parameters. That is, we have to find the Z parameter of the circuit. Determine whether the network is symmetrical and reciprocal. Symmetrical, we have already learned the property of symmetry, and the final result was that symmetry, for a system to be symmetric, Z11 should be equal to Z22. That is the condition for symmetry. And for a system to be reciprocal, then Z12 should be equal to Z21. So first of all, we have to find the Z parameters and then we have to verify these two conditions. So here we have 3 meshes and only resistors are there. So we need not draw a transformed circuit. If there were inductors and capacitors, we should draw the transformed circuit and then calculate the Z parameters. So here there are only resistors, so directly we will go to the equations. So this is mesh 1, this is mesh 2, and this is mesh 3. So we'll write the equations. First one, V1 minus 1 into I1 minus I3. See, this current is flowing in this direction and this current is flowing in this direction. So I1 minus I3 minus 2 into, both these currents are flowing in the same direction. So I1 plus I2 is equal to 0. So we'll rearrange this by grouping together the I1, I2 and I3 coefficients together. This is equation 1. Now we'll go for the second mesh. We have V2 minus 3 into, both the currents are flowing in the same direction. So we have V2 plus I3 minus 2 into I2 plus I1 is equal to 0. Now we'll group together I1, I2 and I3 coefficients. This is the number 2. Now we'll go for the third mesh. Minus 4 into I minus 3 into plus I2 minus 1 into I3 minus I1 is equal to 0. Now we will rearrange this. This is equation number 3. Now we want to bring these two equations to the Z parameter equation form. That's the Z parameter equations, basic equations are these. So in order to bring the first two equations to this form, we have an I3 here, and in this equation we have to replace these two I3s in terms of I1 and I2, and we will get I3 in terms of I1 and I2 from this equation. From equation 3, I3 is equal to 1 by 8 I1 minus 3 by 8 I2. This will be equation number 4. Now we have to put 4 in 1 and 4 in 2. First let me put 4 in 1. This is equation number 1. You have to put 4 in 1. That is, now we have an equation in I1 and I2 alone. Now we have to make it group together the parameters of coefficients of I1 and I2 and put it in this form. This is equation number 5. Now we have to put this 4 in equation number 2. This is the equation number 2. So we can put this I3 here. V2 is equal to I1 plus 5 I2 plus 3 into 1 by 8 I1 minus 3 by 8 I2. So we can group together I1 and I2 coefficients to get it in the form of the second equation of the Z parameter form. Let this be equation number 6. Okay, so now we have got the two equations in the form of Z parameter. So we can write the Z11. So these are the Z parameter, Z1, Z12, Z21, Z22. So now we can check the reciprocity and symmetry. For symmetry, the condition like Z11 is equal to Z22. Okay, this was the condition. But here Z11 is not equal to Z22. So not symmetric. The Z parameter system is not symmetric. Now we'll go for reciprocity. The condition for reciprocity was Z12 is equal to Z21. Here we can see both are equal to 19 by 8. Therefore, the system is reciprocal. Okay. That's it